Okay, so in this video we're looking at 3D Pythagoras, which is a grade 7 topic, and it's really important for this video if you haven't seen this Pythagoras stuff at the grade 4 level, okay, where you've got a right angle triangle with 3 sides, because Pythagoras is also with sides, and your labeling of a triangle ABC. If you need to recap that, you can watch my video in the link below, which looks at Pythagoras at the grade 4 level. Because really, Pythagoras at the grade 7 level in 3D is just applying what you know about Pythagoras in 3 dimensions. Okay, so for example, if you were given this cuboid down here below, you might be asked to find a length, because Pythagoras is also with finding missing lengths, AG. Okay, so we'd be finding this length here from A to G, okay, and then you'd be drawing a triangle within that space, and we're going to see how we would go about and do that now. It's just applying it's about applying Pythagoras in 3 dimensions. So again, make sure, if you haven't done so already or you need to, you can watch my video on grade 4 Pythagoras in the link below. So I'll go through 2 examples on 3D Pythagoras, and then you can try a couple of examples yourself later. Okay, let's begin with this question, which says, first of all, part A says, find the length D to G, and this one's a slightly easier case. Well, my length D to G is going up from here, and then I've got to go and complete a right angle triangle, because that's what Pythagoras is all about. So I can do that by going from D to C, and then C to G. And let's go and label that over here. So I've now got this triangle here, where I've got my length D to G, and I recommend that you label your points up D, G, so you can see what is going on, and you've got the point C also down here. And really importantly, this angle here is going to be a right angle, because you've got a vertical plane, meeting with a flat plane. So this angle is going to be a right angle, which is really important. This stuff here, these letters, has got nothing to do with Pythagoras' theorem. It's just how the triangle has been labelled from the diagram, okay? And we know that the length D to C is 4 centimetres. We know that C to G is 5 centimetres. What's a little bit neater is 5 centimetres. And we're trying to find the length D to G, which is this length here. So let's go and call this X, because we're trying to find it. And then Pythagoras, right, step 1, always you label your triangle with C being your longest side of the hypotenuse, and A and B being your 2 shorter sides. And now it's just a case of applying Pythagoras' theorem. Okay, so it's just saying we know that the theorem states that if you square the 2 shorter sides, so A squared and B squared is equal to the square of the longer side. So A squared, where A is equal to 4, so we've got 4 squared plus B squared, where B is equal to 5, so plus 5 squared is equal to C squared, or C is the missing side, which I've called X. So let's go and put it in to be X squared. 4 squared is 16, 5 squared is 25, and that is equal to X squared. 16 and 25 is 41, and that is equal to X squared. I've got to go and find X, so I've now got to go and square root that 41. So X is equal to the square root of 41. Now, this is my answer. Okay, if you wanted to, you could put it as a decimal. So if you wanted to go and put this into your calculator, you could also do that. Okay, and we can go and clear this and say we've got the root of 41, which is approximately equal to 6.4. Okay, so 6.4 centimeters to 1 decimal place. Okay, both of these answers are correct. This value is what we call your answer in exact form, exact value. Okay, and this is going to be useful for later when we have like 2-step problems, and you're less likely to get a rounding issue if you use this, but this is your answer as well. Okay, so 6.4 centimeters, does it look reasonable? Yeah, because it's longer than 5, longer than 4, so it seems pretty good to me. Okay, so that is looking good, and this is part A of the question. Okay, part B, let's have a look. Let's do a little bit of a dividing line down here. It is saying find the length A to C. So again, on your diagram, let's go and find that A to C is here, and let's go and complete a right angle triangle by going from C to D and then D back to A. So there we go. And let's now go and label up our triangle. So we've got A to C, which is your hypotenuse, your longest side. We've got C going to D, which is down here, and then D back to A. And importantly, again, this angle here is going to be a right angle, because you've got this edge meeting with this edge at a 90 degree. And we know that D to C up here is 4 centimeters. And we know that A to D is 12 centimeters. Okay, so it's really useful to label up your triangle, because you can clearly see, right, AD is this side here. If you didn't label your triangle with the letters from the diagram, you might label the sides with the wrong lengths. Okay, We're trying to find length A to C, which is this one here, A to C. And let's go and call this side here this time. We've used X previously, so really we should use a different letter, like let's go for Y this time. Okay? And then now we can apply Pythagoras' theorem, which is your longest side, the hypotenuse, is C. Your two short sides are A and B in any order. And now we just go and apply the theorem, which states that we've got A squared plus B squared is equal to C squared, where A is now 12, so 12 squared, plus B squared, well B is 4, so 4 squared is equal to C squared, where C I've now called by the letter Y, so Y squared. 12 squared is 144, plus 4 squared is 16, is equal to Y squared. 144 is 16 is 160, being equal to Y squared. So Y is going to be equal to the root of 160, which is your answer. Or you could put it to one decimal place and say that's approximately equal to, let's clear that, the root of 160. Enter it. So 4 root 10, if you simplify the third, or 12.6. So that looks good to me. So 12.6 centimeters. Okay, and let's highlight the answer in a bit of yellow. Looking good. Okay, there we go. There's your answer. And let's just do a bit of a check. Well, this length there is your longest side, which is longer than this side and longer than this side. So it seems pretty reasonable to me, which is good. Okay, let's move on to an example 2, which is a slightly harder case. And this one is saying this time to find the length AG. And okay, let's first of all, let's go and put that on our diagram. AG is here, and let's create a right angle triangle by going from A to C and then C to G. And let's go and put it over here. So I've got my triangle, which is here, which is A up to G, and then G back down to C, where this here is my right angle, because I've got the vertical edge meeting with a flat place. Okay, so it's going to give me a right angle at this point here. And if I go and label what I've got on that triangle, well, A to C, I don't know what that side is. I've got no information about it. I know that C to G is 18 centimeters. 18 centimeters. So that's really messy. 18 centimeters. And I'm trying to find my length A to G. So let's go and call that missing side length X. Now the issue is with Pythagoras, you need 3 sides to do it. I've got one, a missing side. I've got this side. I need this side, AC. So I've got to now go and construct another triangle with AC in it, which I can do by looking at triangle AD to C back to A up here. Because this triangle ADC, okay, AD to C, where this angle here is a right angle, okay, I've now got information to get AC, because I know that AD is 10 centimeters. I know that DC is 7 centimeters, and I'm trying to find A to C, AC, which is here. Let's go and call that missing side length there Y, because I've already used X. Okay, so once I go and find AC using this triangle, I can then go and put this length AC and put it into this one to find this length. So let's go and do that. By beginning by labeling my triangle, Pythagoras, again, 3 sides, A, B, and C, where this side, my longest side opposite the right angle is C, and my 2 shorter sides are A and B. And then applying Pythagoras' theorem, which again is A squared plus B squared is equal to C squared. Okay, and A, this time, A is 10, so 10 squared plus B squared, where B is equal to 7, so plus 7 squared is equal to C squared, and C is that missing side, which I've gone and called Y, so plus equal to Y squared, sorry. 10 squared is 100, 7 squared is 49, being equal to Y squared. So 149 is equal to Y squared. Therefore, Y is going to be equal to the square root of 149. Now this time I'm going to leave my answer in exact value form, because I've got to go and use this value again down here, and I don't want to get any rounding issues, so I'm going to leave it as root 149. You could, if you wanted to, put it as a decimal. I'm not going to, okay, because I want to avoid a rounding issue. But now I know that this length, which is Y, okay, missing side Y, which is A to C, okay, I can go and put it in my triangle down here and say that A to C is got a length of root 149 centimeters. Okay, so now I've got 2 sides, okay, and the missing one label that Pythagoras. Longest side C, opposite the right angle, two shorter sides A and B in either order. And then we can go and apply Pythagoras' theorem again. So let's do that and say we've got a squared plus b squared is equal to c squared, where a is equal to root 149, so root 149, and you've got to square it plus b squared. B is 18, so plus 18 squared, being equal to c squared. Now, if you square a root, because they're inverse operations, they cancel. So you get left with 149 plus 18 squared, I think is 324. Let's just double check that. 18 squared, I think is 324. It is. That's good. So 149 plus 324 is equal to c squared. 149 add 324 is going to be 4. Let's just put it into a calculator. We don't get any mistakes here. AC. So 149 add 324 is 473. Okay, so we've got 473 is equal to, and sorry, c squared, where c is my missing side, x. So I should really put x squared in it. So 473 is equal to x squared. Now x is going to be equal to the root of 473. And the question is saying give your answer to 1 decimal place. So now I've got to go and put this in my calculator. And let's go and get it back up again. So there we go. And put in root 473, enter it, and then put it as a decimal. Oh, sorry, 473, and let's enter that, and let's change it 21.7. So 21.7 centimeters is my answer for this one. Okay, highlighter, there we go. Okay, and my answer is given to 1 decimal place. So just this time I had to use Pythagoras twice, okay, and there we go. That is example 2. So now what you can do is you can try a couple of questions yourself. So question 1 and question 2. What I will do is I will go through each question individually and then put the answer back up on the screen at the end. So if you want to, give these a go. You can fast forward to the end of the video and I will put the answers on this screen for you to check your work. And of course, at any moment you can rewind and check your answers as I go. So the first one we've got below is a cube, and that's a very important word because that's going to mean that every single side is going to be equal to 5 centimeters because every length is the same in a cube with 5 centimeters. And it says find the length AG to 1 decimal place. So AG is here. Let's create a right angle triangle by going C to G and then back to A again. So I've got this triangle AC up to G. So I've got AC back up to G, where I know that this angle here is going to be a right angle, okay, because I've got a vertical edge on a flat plane. Okay, so this angle at the point C is a right angle. I know, because it's a cube, that this length, C to G, must be 5 cm also. So let's go and put that up here. So that's going to be 5 centimeters. I don't know what this length is, A to C. I can't say this is 5 at all because it isn't the same as these two here. So I don't know what this is. And I'm trying to find A to G. So let's go and call that X. Now, the issue here is I've only got 2 bits of information. I've got this, but I need something else here. I need the length AC to end up getting AG. So let's get another triangle which includes AC, which is this triangle, AB to C, back to A, up here. Good, so I've got this triangle, A, B to C, B to C, where this angle at the point B is a right angle. Let's go and put it in. I know that A to B is 5 centimeters. I also know that B to C must be 5 centimeters because it's a cube. So I've got 5 centimeters here. So I can go now and find A to C. Let's go and call this side here length Y. Once I get AC, I can put it back in down here later. Good. Pythagoras now labeling up my triangle. I've got my longest side C, my 2 shorter sides A and B. Okay, I can go and apply my formula, which is A squared. Oh, what's happened here? What's happened there? That's not good, is it? Let's go back up to this. There we go. So back to A squared plus B squared. Oh, what is happening here? This is not good. Something is glitching out a little bit. Okay, a squared plus b squared. Why is that happening? Sorry, guys. This is very strange. Okay, I'm not sure what's happening there. That's very strange. That's really strange. Seems like if I press up here. Right, that's just a squared plus b squared. That's very I'm not sure what happened there. Sorry, I think for some reason I pressed up here. Everything was a bit of a glitch. Anyway, we're back in action. A is down here, which is 5. So I've got 5 squared plus b squared. B is equal to 5 again, so plus b squared is equal to c squared. So I've got 5 squared, which is 25, plus 25 being equal to, c was my missing side, which is y, so y squared. 25 and 25 is 50. So 50 is equal to y squared. So y is going to be equal to the square root of 50. And again, I could put it as a decimal. Because I've got to use it again down here, I'm going to leave it in exact value form, okay? Because I won't get any rounding issues. And y is my length a to c, to make it really clear. Okay, and AC is also down here, which is really good. So I can go and put it down here and say that this length here is root 50 centimeters. Okay, good. So if I go and draw a bit of a divide here, and now use Pythagoras again down here, where C is my longest side and A and B are my two shorter sides. There we go. And let's go and apply Pythagoras' theorem again. So A squared add B squared is equal to C squared. A is equal to root 50, so it's going to be root 50 squared plus B squared. B is 5, so plus 5 squared is equal to C is x, so plus equal to x squared. Again, the root and the square are inverse, they cancel, so you just get 50 plus 25 is equal to x squared. So you've got 50 to 25 is 75 is equal to x squared. Therefore, x is going to be equal to the root of 75, okay, which we want to give the answer to one decimal place. So now we need to go and get out the calculator and type in root 75, which is equal to 5 root 3, or 8.7 to 1 dp. So 8.7 centimeters, okay, highlighter, to 1 decimal place. Okay, so that is your answer to the first part. And let's go and put that in over here. So the first answer was 8.7 centimeters. If you got that, really well done. Question 2. Here we go. And it says, calculate the length of the diagonal B to H. So we've just drawn that up here. So BH is this length here. And I've got my right angle down at the point over here. So this is over here. So I've got B to D to H. Let's go and label this over here. So B to D up to the point H up here, where my right angle is at the angle D. I'm trying to find B to H, which is my missing side. Let's go and call this X. I've been given B to, no I haven't, I've been given D to H, which must be the same thing as CG, because they are the same edge in the cuboid. So this must also be 2 centimeters. So D to H is 2 centimeters, but again, I'm missing this length here, D to B. So I've got to go and use that using a second triangle, which I can go and do by looking at this. Okay, DAB, dab, there we go. So I've got DA to B. So point A is the right angle, D's up here, and then the point B is down here. I know that A to B is 5 centimeters, and I know that, well, AD must be the same thing as BC, okay, because they're the same edge in the cuboid, so that must also be 3 over here, so this must be 3 centimeters. And I want to find my length B to D, which is this one. Let's go and call it Y, so that, there we go. Now using a bit of Pythagoras, okay, 3 sides opposite the right angle is C, 2 shorter sides A and B. And I'm putting it back into our formula, which is A squared plus B squared is C squared, okay, where A this time is equal to 5, so I've got 5 squared plus B squared, or B is 3, so plus 3 squared is equal to c squared, or c I've called y, so y squared. 5 squared is 25, plus 9 is equal to y squared. So I've got 34 being equal to y squared. So y is equal to the root of 34. And of course, y is my length d to b. So d to b is equal to root 34. And again, because I'm using this down here again, leave it in exact form because you won't get any rounding issues. So I now know that db, which is down here, d to b, is equal to the root of 34 centimeters. I can use Pythagoras because I've now got 3 sides. So I've got my hypotenuse, c, my 2 shorter sides, a and b, in either order. Okay, so putting it into my formula, a squared, b squared, c squared. Where a is this time root 34, so it's going to be root 34 all squared plus b squared. So plus, well, b is 2, so plus 2 squared equals to c squared. C I've called x, so equal to x squared. And again, the root and the square, they cancel. They're inverse operations, so you just get 34 plus 2 squared is 4 equals to x squared. 34 of 4 is 38, being equal to x squared. So x is going to be equal to the root of 38. And then you go and put this into your calculator. Oh, no, sorry. This one says give your answer as a surd. Okay, so it's crucial in fact that you didn't round this to a decimal. Otherwise, you would get a decimal answer down here. So it's very, very important that you must use a surd. Sorry, a surd means you've got a square root sign. So if you rounded this to a decimal, okay, and you put it into this, you would not get a surd answer at the end. Okay, so that's really important here. So actually x, which we know is our length b to h, okay, so x, which is equal to your length b to h, as a surd is root 38 centimeters. Okay, so really, really important. This time, we do leave it as this, okay? That is the same thing, right? If you did get your answer to be equal to, let's just check it, because you might have gone through and done, well, root 38, which is equal to 6.2. So you might have put 6.2, but you must have your answer as a surd. That is crucial. So you can't have this one. So root 38 is your answer here. And that's, put that back on here. So we've got root 38 centimeters is your answer. Okay, so if you fast forward to the end of the video and you've checked your answers, question 2, it says give your answer as a surd. Okay, so it's really important that you wrote root 38. If you put 6.2, okay, well, you're not really wrong, but it wants it in a specific form. A surd means you're using a square root sign. But anyway, that is it for 3D Pythagoras. We'll be on to 3D trigonometry in the next video, and hopefully that was useful. Thank you.